Assalamualaikum and hi everyone. My name is Nurin, Jazlina Binti Azizan, along with me Aiman, Hakeem bin Abdul, Haleng, Khanga, and also Muhammad, Danial, Irfan bin Mahmmoud, El-Saffaah. We are from Group 7 of CS 1121A for subject MAT183. We are going to present topic applied maximum and minimum problems. So let's get started.
Introduction of Applied Maximum and Minimum Problem. Applied Maximum and Minimum Problem is a problem under the topic of application of differentiation. The process of finding maximum or minimum value is called optimization. We have used derivatives to find the maximums and minimums of formula function, but it is very unlikely that anyone will actually give you a function and ask you to find its extreme value. Usually, the most challenging part to solve the problem is understanding the problem and translating it into mathematical form. All the problems require understanding, translation, solution, and checking to solve it. If we relate this problem in real life, typically people will describe the problem and ask us help to maximize or minimize a quantity. For example, what is the quickest way to get from here to there? What is the largest volume of a package that the post office will accept? And what is the least expensive way to accomplish some task?
So here I'm going to explain about the problem statement that we have. Okay, figure 1, which is this figure, shows a rectangular storage area with width x meter and length is y meter to be constructed along the sides of the tall building. The tall building is actually referring to this particular rectangular, which is the rectangular in the gray color. And then it states that a security fence is required along the remaining three sides of the area. Remaining three sides of the area, which is referring to this side. This side, this is not included. Okay, that is actually just these three sides. This sides. Okay, and then it asks us what is the maximum area that can be enclosed with 800 meter of fencing. So from this statement, what is the maximum area that can be enclosed with 800 meter of fencing? We got that 800 meter is actually equals to perimeter of these three remaining sides. X. So we got 2x. Sorry. So we got 2x plus y equals to 800. Okay. And then they ask us to find out maximum area. So we have to find dy over dx and then continue with d square y per dx square to identify whether it is maximum or minimum value. And let's look at the solution.
So now we are looking for the solution method for this question. First, as we know, to get an area for a rectangular is length multiplied by the width. So y multiplied by x. So we got the area is equal to x multiplied by y. Next is the perimeter. We know that perimeter is mass 2x plus 2y, but for this question told us that it just only 3 sides because this side is doesn't have any security fence on it. So we know that only 2x here plus y. So we know that perimeter is equal to 2x plus y, and the question gives us the total perimeter of the security fence, which is 800 meters. So 800 meters equals to 2x plus y, and we want y as the variable, and we got y equals to 800 minus 2y. We put this equation of perimeter here into the area, so we got x multiplied by 800 minus 2x because this is equals to 2y. We put it on this equation area, so we got 800x minus 2x squared. So we are looking for the next step for this question. Okay, so now we are going to derivative this equation with respect to the x. So we got dA over dx because we are going to we're going to differentiate the x, so we must respect to the x. So we got dA over dx equals to 0, and the 800x minus 2x squared, when we differentiate it, we got 800 minus 4x equals to 0. So now we want to get the x value, just the x. So what we are going to do is we bring the negative 4x to the right side, to the right side, and we got 4x equals to 800 meters, and we bring x because of 4x, so when we bring to the opposite side we must divide it, so x equals to 800 divided by 4, so we got x equals to 200 meters. And then when we know the x value is 200 meters, so we are going to put the 200 meters of the x value into the equation of the area in the first step. So we know that the value in the first slide is y equals to 800 minus 2 multiplied by 200 meters. So we got y equals to 400 meters here. Now the question wants us to get the maximum value. So how we want to get the maximum value is we're going to make a second derivative from the first derivative answer, which is 800 minus 4x. So we got negative 4 here. So we know that negative 4 is smaller than 0, so the value of 200 and 400 meters is the maximum value. So the maximum area for this x multiplied by y is 200 multiplied by 400 equals to 80,000 meters squared.
For the conclusion, apply maximum and minimum is useful to our lives. Based on the question that our team has done, now we can know the maximum area that can be enclosed with 800 meters of security fence by using the application of maximum and minimum. It made their job easier to be complete by using this application. So, learning to apply maximum and minimum is not in vain, because who knows how this application may help us in the future.
So this is our reference, and that's all from us. We hope you guys enjoy and understand this video, and thank you.